The recording is on. So welcome everyone to SQL Friday. I think this is number 94. So we're approaching the SQL Friday number 100 celebration. Milos is coming back. You were here last season as well. And today Milos is going to talk about parameter sniffing in SQL Server 2022, right?
Yeah, that's correct.
So, Milos, I leave it up to you to present yourself and the session. This is one of the features I'm looking forward to the most with the release of SQL 2022, actually.
So great. Thank you very much for hosting this session and having this SQL Friday. I think you can see my screen now.
I see the screen, yes.
Yeah, so parameter sniffing in SQL Server 2022. So my name is Milos. I'm head of SQL engineering at Entane. I guess that most people who attend this session or such sessions know about us, and I will not talk about this here. You can see here some my contact data. So LinkedIn contact, just search for my name, and you can find me on LinkedIn, add me on LinkedIn if you have questions related to this session. So I think that I have many sessions that starts with similar slides. It's basically what happens when we send a query to SQL Server database engine. What happens and that we are not programmers when we write the queries. We are more project managers. We tell SQL Server what we want to do, what we need from him, and SQL Server needs to create a plan and to find out to implement this request. And what happens are these four phases. SQL Server goes and check first syntax, check whether these objects exist in the database, and then combine all these things, check constraints, metadata, and then it comes to optimization. So SQL Server need to find out the way how to reach from A to B. You can go with food, you can go with car, you can take for instance, to go to Munich from Vienna, you can take train and you can go with flight and you can fly there. And it's about 4 hours, both you are in Munich in both cases. So it's basically different ways to deal with this. What SQL Server checks is are statistics, metadata information, cardinality of tables, some assumptions, internal rules, and after that, he just combine different ways to do this and different ways or potential execution plans. And when it finds this plan, because this is for complex queries can be very expensive information, it put this plan in cache. When this plan is done, it's sent to execution engine, and execution engine has a lot of operators who can execute the query. So this is not a cheap thing. So all these phases, whenever you have especially complex queries, and it makes sense to put this plan in cache when you're done. That means when you call the same query again, that SQL Server does not need to go again through all these phases to take the plan from cache and do this thing. And this is valid. This is by default in SQL Server. When you try the same query, SQL Server will take this from cache. Makes sense. So what is parameter sniffing? Parameter sniffing is related to queries that have parameters or store procedures. So in addition to all these considerations, statistics, indexes, should I use this index at all? Should I use index can and 6 and so? SQL Server considers the parameter values for the first call. When you have a store proc, the most important call for a store proc is the first call, because first call decides about the future plans. SQL Server sniffs values and creates exactly the same plan as it would create when you just write this big select with literals there with these parameter values. And this is basically then used for all future calls. And this means for all future calls with the same parameter value, and for different parameter values. Regardless of parameter values, you have a plan for this store proc, I will use it. And this is not bad thing by default. So, but sometimes it could be a problem. So it's good thing. So parameter sniffing is good thing when the first call is representative for all future calls. Then you're good with parameter sniffing. So what you can see in parameter sniff, I have just a few slides and then I will go to Management Studio and I will not go back to slides. So in the execution plan, when you look at parameters, when you look at the execution plans, you can see parameters, two values: parameter compile value and parameter runtime value. This is a thing which is this plan is made for. That was the first call of this store proc. And this is the current call. This is current value parameter. This is my first call. Then in this case, it's they are the same. And then I call the same store proc for the second time. But you can see here that this is a use parameter, but the plan has been created for 1, 2, 3. So if I have similar plans, if both customers are okay with this, then it's a good thing. You can see this also in XML. When you go there, when you go to XML representation execution plan, you can see this too. What happens when the plan is removed from cache in restart server or SQL Server instance after failover cluster, when you change big things on the database like mark stop, when you have memory pressure on server, when the plan is evicted, and when you run this queries with this commands, dbcc free proc cache after you alter stop proc, regardless of changing if you change or not the definition of stop proc. When you run alter proc, the plan is evicted from cache. When you call CPU recompile, when you rebuild, when you add the index, when you rebuild, remove indexes, and you have significant changes in database and in statistics. A lot of entries here, but if you have a very important stop proc, which is frequently called, usually you have this plan all the time in cache. So if you don't have memory pressure, let's say from until the next failover or patching, you will have this plan, single plan for stop proc and cache. You have one plan per stop procedure. The good, bad, and ugly with parameter sniffing. So this is not a problem. You can find a lot of sessions. Parameter sniffing is a problem. So it's not always the problem. This is a behavior or phenomenon, and this phenomenon is sometimes desired. Sometimes it doesn't matter whether it exists or not. Sometimes it's bad, it can slow down a bit application services, but it's not so significant, and sometimes can be really catastrophic for both for applications and for server. This is just one example. We will go back then. We will switch to code examples. Here is just an example of parameter sniffing or a good parameter sniffing. So on the left side, you have a execution time 90 milliseconds for some workload or the stop proc with parameter sniffing effect, and without parameter sniffing 1.2 seconds. So it's not always bad. It's 14 times faster. This is an example of bad parameter sniffing. This blue line. So yesterday I had a 386 milliseconds of time. Today is 45. It's a good. But yesterday with this other parameter combination, I had 400 milliseconds. Today, 4 seconds. It's 10 times slower. So I have spikes in execution times. And this is an ugly thing. So yesterday I had 45 milliseconds and today 32 seconds. So this means very same stop proc, very same parameter, nothing changed. Yesterday 45 milliseconds, today 32 seconds with 40 million logical reads. This is the parameter sniffing. So when parameter sniffing harms performance, when we have a multiple plans. So when we have a single plan for all calls, then all is fine. When we have a multiple plans for different calls, when we have a different operators, that's scan versus seek, or when you have a different indexes, you search first for customer ID and then for order date. And when you have a significantly also different memory requirements, you have the same plan, but your query returns few rows and then return a few million rows. And we have a problem, the plan must be in cache. When plan is not in cache, then we don't have a parameter sniffing problem generally. And we have a significantly different parameter values. Typical examples for store procs or queries prone to parameter sniffing: optional parameters. When you have a customer ID, you search for customer ID and order date, and both of them are optional. And you have this customer ID equals this, or customer ID parameter is null. So this kind of optionality. This is a great example of parameter sniffing. Then you have equal operator customer ID equal customer parameter, but data distributions is skewed. You have outliers. Then For instance, one customer has 1 million orders, the other customer have 5 orders, both of them are customers. And when you have give me all orders for customers, then yeah, it's a skewed distribution. Inequality operators give me all orders with order date greater than something. This something can be in the future, can be in the past. So depending on this, it's different execution plans. And typical example is also, from and to date. You have some reporting and you have a from date and to date, and nobody put any restrictions there. And basically you risk that somebody will use some, 2 years range for this and so on. This is not limited for star procs only. It's also when you have a dynamic SQL CP execute SQL in dynamic SQL. This is also system star proc. Parameter sniffing in 2022. What does it mean? So they have a feature called parameter sensitive plan optimization. This is a part of intelligent query processing feature family. It lets you have multiple active execution plans in cache for a star proc or parameterized query. So the thing is that for now, till 2019, we have a single plan per star proc in cache. Now you can have more. And how many plans? It's up to 3. But I did not find strictly documentation telling it could not be more than 3. It's exactly 3 or something, it could be more. So when this thing will be activated, parameter sniffing optimization, and how many plans and which boundaries, it's up to SQL Server database engine. I did not find strictly confirmation documentation that this is exactly these values, this number of plans and this boundaries. This is a image from SQL Server documentation. Whenever SQL Server see there is a parameterized query or star proc, there is a dispatcher plan and check cardinality, estimated cardinality. If this parameter will have less than here, say 10,000, then you will have a one plan. If you have between 10,000 and million, you will have another plan. And if you have more than 1 million, you will have a third plan. This is not always correct. So in my cases, I had sometimes that boundary is 100, not 10,000. Therefore, I tell it's not clear for me whether this thing is dynamically changing, or we can have at least what I saw that we can have up to 3 ranges here. So let's go back to the previous slides to see which things that we are typical parameter sniffing will work in 2022. First one won't work. So if you have optional issues with optional parameters, you will still have these issues in 2022. This is not touched at all. This one, inequality parameters, also operators won't work. Order date greater or less than or between won't work. And if you have also this kind of things, it won't work. The only thing with which will work is equal parameter, equal operator, customer ID equals something. And this is also there are restrictions to this. It doesn't work for all combinations. Okay, let's go to demos. Any questions so far? I guess no, I didn't tell too much. So here is my 2022 instance. This is a release candidate 1. So of course, everything related to 2022 is still in preview. And it might happen that this will not be part of GA solution of public release, or it will be changed. So all this you need to take with reserve. Let's go first to an example of good parameter sniffing, because parameter sniffing has bad reputations, especially in conferences and sessions. Let's go here to find a good parameter sniffing. So here I have a table, sample database and events table with about 3 million events, and have just few events in the future, just for you, for your information about this table. And I have a star proc get events since. I just want to give me all events after some date, and this is a generic star proc. Let's go here and execute this, and I will have the same star proc with disable parameter sniffing. So this is a hint that tells SQL Server do not sniff parameters for this star procedure. So I just want to show you that parameter sniffing is not always bad. And I have another instance here. And then I will call this star proc with today's date. Usually I want to call this star procedure to get future events, or I can even take events from yesterday or something. So basically, I plan to use this feature with future dates or maybe few days in the past, but not 5 years ago. So this is my intention. I know my intention in this in my application, and I will now execute this store proc, and you can see a good plan. Of course, I'm a good developer. I search on event date, and basically I index this event date, and this is an index on event dates, and this is the plan what we have expect. So this is just a few rows. I have only 9 events in the future, and all these things is basically is done now here with all good performance we can see here. When I use the same thing with get event since too, where I have disabled parameter sniffing, it's not so fast. It's not so terrible slow, but it's not so fast. You can see here that this thing is now 1.3 seconds with 200,000 logical reads. That's in SQL Server had to read 200,000 pages to generate result for this query, and what it does cluster index scan. It scans the entire table. Also, I have an index there. That means parameter sniffing helped me here, that the way that they sniff the parameter, it optimized for the first call, and then I had benefit of parameter sniffing effect. So this thing is not always bad. So this is slow. So say again, it's a bit better now because it's in cache, but again, it's still scan and it's still 200,000 logical reads in about 300 milliseconds, and this thing is instantly done. So it's basically I don't spend 44 logical reads, actually 30 milliseconds. So this is a good parameter sniffing. So if parameter sniffing would be so terrible, SQL a team would disable this feature. So this is a desired behavior in many cases. Whenever you have a call, your first call is representative for all future calls. This is the criteria for parameter sniffing. But yeah, sometimes it's not this case, and we are talking now about problems in parameter sniffing. So I have here another database DB2. And here is my, again, orders table, and I have a skew distribution in this orders table. I have 2 customers reselling my orders. So one has 1.1 million orders, another has 900,000 orders, and all the other customers have about 1,000 orders or less, and few of them have even just a few orders. Altogether, I have about 10 million orders in this table. So it's a skew distribution. And when I run this selects, you can see here that the first one is 1.8, 900,000, and just 2 orders for customer 4796. And this is my store procedure. My store procedure is just to give me amount, total amount, and number of orders for customer. And of course, we can have here different plans depending on customer ID. If I would execute this query here with customer ID number 1, this is the plan that I will see here. Cluster index seek, cluster index scan, because I have 10%, more than 10% of all orders belong to customer 1. So logical thing. Customer number 2, this is the best plan according to SQL Server. Again, is cluster scan even for customer 2. And for this customer, his plan is index seek followed by keylookup. Here we can say that we have 2 different plans. For customers having a few orders, we have an index seek followed by a keylookup, and for customers with a lot of rows, a lot of orders, we have scan. This is a typical example. You have a lot of rows for something, scan, seek. And how is this handled in before 2022? This is default behavior in 2019 with all this intelligent query processing, whatever. So I will call this for the first time with get orders total 1 for customer 1, then for 2, then for 4796. So we saw here that first two calls are scans, and the third should be seek. But when I call this in with store proc, we have the same plan for all calls. Even this one, when we know we have just 2 rows, SQL Server has used cluster index scan because plan is already in cache. And this thing is, if I recompile the stop rock and do opposite, you can see now that's not so fast, because now SQL Server use this plan for all calls. And here you can see this declines. The SQL Server had to repeat this action a million times, and you have a huge amount of logical reads. Let me check, show logical reads here. I'll repeat this. So look at this number. This is a 4 million logical reads. So I have about million rows and 4 for each seek. I need to do KLOOKUP 4 times. It's basically 4 million logical reads, and this is a huge amount of reading. What happens in 2022? This is default in 2019 and all previous SQL Server versions. In 2022, what happens now? I will do the same. I will run all these 3 queries. And here magic happens. So here is, it's okay. We want to have scan for this. This is okay. We want to have scan for this. And this is a great, because now we have a seek. So I have 2 plans within the same stop rock, which is a good thing. And this is now that should be faster than initial one. We will measure this this thing. And if I recompile this thing, it doesn't matter what is the first call. So under 2022, with parameters sensitive plan optimization, importance of the first call is significantly reduced. Here, it doesn't matter. I will repeat this with this thing, and SQL Server will go again. Okay, I will create this plan first, then this, then this. We still have 2 plans. Is it good? How much performance win should we expect here? Let's use here SQL Query Stress tool. I guess that everybody is familiar with this. If you're not, just Google SQL Query Stress and other mechanic. This is author of this tool, and now I think Eric Hansen is supporting new versions of this, and you will find it. It's a very simple tool. Let me to execute the same one query or queries or workload in several iterations and with multiple threads. I will just execute 10 times this workload, and let me copy this, my workload. So here is a 1, 2, and 4, 7, 9, 6, and I will go back to 150 compat level. Let me just, yep. So I will go back to 150 compat level, and now just remember some time. So it will take 5 seconds, about 5 seconds in 2019. And I will switch now to 160. So we just buy a new version, we upgrade the server, we change compat level, and we want to see improvements. Do we have improvements? Yeah, we have. 342, there was a 5 seconds, now 342. And yeah, it looks good. Let's go the opposite example. So recompile. I will just take my workload number 2, go back to 150. This one was even slower because we have now index seek followed by KLOOKUP for all calls. For first call, it's a good. For second, is not. For third, is not. And then you can see here from execution time. Now it's already 12 seconds. It will be about 30, more than 30 seconds here, or even more. So this is what we have in 2019. And in all previous versions, it's not related to 20. There is no, it's not a bug. It's a default behavior, and we have a single plan. This plan is unfortunately not good for the entire my workload. It should be about 30 seconds, more than 30 seconds. Let's go 38.37 seconds. So this is a time in 2019. Let's go to 2022 and repeat this thing. Oh, it's again about 3 point some. We see that we know this time from the previous comparison. It's about 3.5 seconds in both cases, because in 2022 it doesn't matter what is the first call. So it's a significant thing, of course. So from 37 seconds, so you just get it. You get it for free. I did not touch my code. What I did is basically to change compat level for 160. Okay, all fine. Questions?
I have one, or actually two.
Yep.
One is there are more things that the optimizer have to check before actually executing a plan with sensitive with this parameter sensitive plan optimization. So will that in itself reduce execution time for simpler things? Will it add CPU cycles to the pre-optimization of the query?
So in all my tests, I did not find significant overhead during these considerations. I think that they do this quickly enough, so I did not find it. Doesn't mean it doesn't exist. But honestly, I play with simple queries. So I did not play with some huge, very complex queries with this, where this consideration could even, you can have, for instance, 10 different parameters, and SQL Server needs to check all of them. I did not check this, honestly. With a single parameter over 2 parameters, I did not find any significant overhead by doing this.
So the second one is the option to not. I don't remember the name of the query hint, but the one to not use parameter sniffing. What does that in reality do? Will it optimize the plan for unknown?
It won't. There are many things. I have the entire file for this. There are many things where parameter sniffing optimization will be skipped, and one of this, if you disable parameter sniffing at any level, at store proc level or at database level, of course, it won't work then. So there are. Yep.
But it still has to use some kind of value to create a plan. Will it just do optimize for unknown and under the hood, or what will be the approach that the optimizer uses when you disable parameter sniffing?
If you disable parameter sniffing, it will not sniff parameters generally, and it will behave as it behaved in 2019. So in 2022, PSP will not be triggered at all.
Okay.
So there will be very small overhead. They will check, okay, parameter sniffing is disabled. I will not check. There is extended events. I will show them. I have a demo for that. There is extended events that shows exactly why parameter sniffing optimization is parameter PSP is skipped. Okay, I just want to show here some change in execution plan. When you look at the query with 2022, you see here the query itself has been changed. They put here plan per value something. When you just go here, and you can see that that my query got another here something from Microsoft, and telling this is object ID, this is a query variant ID 3, and there is also predicate range, which is defined. They say, okay, customer 100 and 1 million. So this is what I get automatically from PSP, and this is something called query variant 3, which means that this parameter belongs to this range number 3. That means this is greater than this value here. And sorry. And when I call the number 2, you will see here query variant 2. That means this is between 100 and this million. And when I call this one, it's number 1. So query variant number 1. That means it's between 0, 1 and 100. So this is basically different. You see that that SQL Server team SQL Server team just put a hint on my query, and this is basically how they implement this thing. Okay, so we saw that's a good thing. We saw a very good example for this. And now I will introduce a fourth customer. My customer number 8000 has 965 rows, actually. And this is greater than 100 and less than million. Okay, and I will repeat this in, we know in 2019 how this will behave. We will get again the same. The first call decides about the plan. The first call is one. I will have scans, and when we go with this and do this, that will be terrible because all of them will have index followed by key lookup. And what we'll see here in 2016 is, again, we will have 3 scans and 1 seek. Okay, and let's see again. Let's use this this tool. I have now different workload. I will just change here my workload 128,000 and 479, and let me check this in 150 mode. So it will be about 6-7 seconds. And go to 160 and do the same. So we're still good. 5 seconds, we have better performance than we had before. So PSP had helped me here. And now I will not repeat this with this thing, with this ideas of first, because you saw it will be 50 seconds and you will get again 5 seconds. It's everything is fine. And now I will slightly change my workload. I will replace this 2 and 800 and 8,000. And I will explain you then why I did it. So I will repeat the same thing. 1 customer, my workload is, I call this for customer 1, then 8,000, then 2, then this customer. And let's go back again to 150. And this is 150. It's about 6-7 seconds. 6.73 seconds. Let's go now to PSP. It won't be 6. It will be higher. It won't be minute, but it won't be 6. So it will be 9, 10. So it will be about 15 seconds. So this is a performance regression. So it was better in 2019 than in 2022. So this is why this thing happens. I switched these 2 things. And these 2 things are 2 customers that belongs to the range 100 and 1 million, both of them. Which means if you strictly say that you will get one plan for customers between 1 and 100, the second for customers between 100 and 1 million, and the third for customers with more 1 million, that means that customer having 105 orders will have exactly the same plan as customer having 995,000 orders. And this is a bit corner case. So this customer has 900,000 something, and this customer has 900 rows. It's basically 1,000 times less, but both of them have the same plan. Which plan will be used? That here decides the first call. So first of these 2, first call within a range. So when I go to 160 and call this here, we can see different plans. So first one is scan. The second is index seek. The third is again index seek, and you see immediately that the index seek is not good here because this is this thickness. And we have 3 index seeks and 1 scan. And if I recompile this and change this to 12800 569, I think. Okay, first. 1 bug, recompile doesn't work. You see it? I get still the same plan. So this is the same plan. I need to go here and do this again. And now you will see scan, 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 seek. So we have 3 scans, 1 seek, because this thing is here. It's appropriated plan for this number 2 is scan. And this one will get exactly the same plan, although this plan is not appropriate for customer 8,000. It would be better to have index seek, but they are in the same range. And this is a basically drawback of this, sampling. So if you want to split this to 3, you need to put some values. And if you put too high values, then basically for me, for this particular example, this value is too low. So basically everything greater than 100 will have the same plan. So this thing has 900 rows. So this has 900 rows. And this thing has 900K rows. And both of them have the same plan. And this is again parameter sniffing within this range. So basically, that's in that manner, it is important which call is the first within a range. So what PSP does is basically it will help you not to have a scan for few rows and not to have index seek followed by key lookup for millions of rows. This is here, that was my first case. This is covered good. What is in this when you have distribution between, that could go in both directions. Here you see that the old behavior or 2019 was in this particular case better, because for this one I would need index key lookup, and for this one I would need scan. If I call this as a first, as in this case, so this is pretty fast. You see this fast. But the same thing when I call it with this, I need to again use this to recompile. It's not so fast. You see the third one is not good, and the third one is about 1.5 seconds, because this thing is, again, look at the logical reads, is 3 million logical reads. And the same thing if I go with other order of calls, I see better performance. It's stable. It's basically it's a scan, but it's 175 instead of 1.5 seconds. So it means PSP is will cover this, big difference. But when you have distribution between these things, between these boundaries, it can be. Again, you have parameter sniffing, as you see. It's a typical parameter sniffing issue, secondary parameter sniffing, I will call it as. So I'm not sure about this 110,000 or million or something, whether this thing is dynamically calculated or it's hard-coded, or it will be. So, and I'd like to know this information. For me, it's important if I want to disable some enable some feature on production system. It's very important, at least for me. And sometimes we do not talk about this in conferences and sessions. Oh, it's a great feature. You need to enable this on production. I can tell you now, enable this on production, but I'm not responsible for any damage that you can make. So it's, I don't care. If I need to enable this in very critical environments, so I need to know about the things. I need to know how this thing works. I need to know how this thing is calculated. I need to trust to some particular feature or tool before I enable this, before I delegate some my responsibility for this feature. I plan to use all features also in 2019 or 2022, but basically I need to know about them. The same thing I have with automatic tuning, for instance. I like query store. This is the feature, the most useful feature for me ever in SQL Server. I use it every day, but I'm not completely happy with automatic tuning because I don't know exactly how this thing works, how it calculates how many milliseconds should be CPU time. I need to know this before I delegate. Hey, you can do this instead of me. So I need to know exactly in order to trust the tool. Here it's again, this is a preview, so I need to really take this with reserve. It's not easy to document all these things, but I would like to know documentation about this. Is this always 100 or million, or it's dynamically calculated? What are possible values and so on? And then, because this thing is, again, a potential problem for me. I do not expect for all features, especially from IQP that works, to cover all cases, but I need to know what this thing officially does in order to prepare myself for such cases. I will let PSP to cover things what is then, but I need to know which cases are not covered so that I need to cover them again. So if you need to, so you expect that parameter sniffing will be solved in 2022, it's not, it won't be solved. So you still need to learn about parameter sniffing and you still need to handle parameter sniffing issues. And I'm afraid it will be also after in the future versions. Okay. Any questions?
There were a couple that I answered in the chat. One was, what if you call a procedure by 100,000 different customer IDs? How many parameter variants? And you answered that it seems to be 3 parameter variants, but it might change. It's not documented.
It's more all my test cases. They were not more than 3. So it was 2 boundaries. You get some number here. I got always 100 and million.
Yeah.
100 and million. That means 1 to 100, 100 to million, more than million, and that basically are 3 ranges. I never got 4 for a single parameter, and I always get this, but I did not find maybe there is some documentation, but I did not find. It could be the same. So that means here it's SQL Server decides what is basically according to cardinality of this call. You have still parameter sniffing within a range. So it's not a big deal to have parameter sniffing between range 1 and 100, because it is likely that customer that has 95 orders will have the same plan with customer having 2 orders. Yeah. It's very likely in large table, and customers having more than million. So it's not the same million and 10 millions, of course, regarding to memory grant, but at least you won't get the wrong plan. But you can still, between these 2 things, of course, just think if you would have the same plan for, that means this PSP tell that the customer with 105 orders will have exactly the same plan as customer with 950,000 orders. If you're fine with this, if your workload is fine with this, then it's not a problem. But if it's not, then yeah.
I guess also if you always need the perfect plan, you always need to recompile the plan, and that will be hugely expensive. So I mean, it's probably better than it was on an average. So and that's all that Microsoft can deliver as kind of out of the box thing, I guess. So.
Yeah, it is. I showed the first example. It's a significant improvement, and you did nothing. But in my opinion, this feature is more for people or companies that do not have enough people or resources to fight against parameter sniffing or something. And basically, you can significantly just upgrade to compat level, and you see a better performance. Some problems will be solved, not all of them, but if you upgrade it, it will be better than in some cases, as here, it could be performance regression, but and I will cover some other drawbacks of the feature.
Yeah.
Soon, and actually immediately. Yeah.
The next other question was, I'm assuming we have to have the statistics up to date, and I answered that yes, if the statistics are bad, the plans will be bad regardless. So.
Yeah, this is the thing. So SQL Server does estimation still. So here is it allows you to have multiple plans, and it will do here according to statistic. If SQL Server thinks that we will have here 5 rows and we have 5 million rows, it will create plan for 5 rows. So for any reason, if you have, for instance, you just, I will show you a few examples that this thing will be skipped, but basically it's still important. It's still the same process that I showed on the first page. So SQL Server still needs to make all these considerations regarding the plan. The only thing is basically that it will store multiple plans per star proc. Okay, so now some drawbacks. Is one of this is plan in cache. So here is I will go back to 150 and we'll call just this stop procedure once. Let me show the plan. So here is this plan is scan. And here, this one is also scan. We have the all good parameter sniffing in 2019. And when I troubleshoot parameter sniffing or any other issues with performance, I look at the execution. Of course, we need to look at the execution plans in cache. And when I go here and check execution plan, I can run this query, go to exec cache plans and find a plan for this stop proc. And this is a plan that you saw. This is a cached execution plan. You see my plan now. And when I recompile this thing, recompile works in 2019, as I saw in 2022, it doesn't seem to work, at least for PSP thing. So this is a new plan. And I can see also this plan in cache. So all fine. This is what we respect, huge respect to have again for all these DMVs that help us in troubleshooting. What happens in 2022? This is, I call this one, I call this twice. You see this plan, you see this plan. We have different plans. We already covered this. Let's go to check the plan in stats. So there is an entry here. I go here. Poof. What is this? There's no plan. So they don't show me the plan. So I can click to XML. I can see a bit more data. And this thing is maybe they show this range of data or something. So yeah, so low boundary, high boundary, and that's all. There's no plan here. And this is the first problem. So if you just somebody claims, yeah, there is a procedure which is low, you look at the plan, there is no plan. And you usually had this in previous versions. And this is, yeah, of course, it's not easy generally to implement all these things, but we don't have 75 plans here. I have just 2. And I would expect here to see both of them, to see plan for variant 1, plan for variant 2. This is just some kind of wrapper, but we see nothing here. And this is, of course, this is a problem for troubleshooting. The good thing is that statistics about the execution is still there. So go back to 150. So in addition to execution plans, we need to check also execution statistics, and see here is in 2019, we see that this store proc has been executed 2 times. Is average execution time is 192 milliseconds and so on. And now I go to 160, and in 160, let's see what will happen here. So we lost this information for the plan, but we did not lose this for here. It's still there. So at least we can use this DMVs shows the results, but the plan is not shown. Another thing is related to query store. For somebody who uses query store, it will be also tricky. So I will go back again to 150 to show that this thing works in 2019. I will execute this 2 times here. And I have a here, because query store works with query IDs and not with store procs, I have a here written some file, some code that will work, that should work at least, will define me a time, and this is a 653. It's basically average execution time for this store proc. So I have some statistics about for this store procedure. I will now clear query store so that we don't mix these things. So there is nothing in query store, but we saw query store will cover this in 2019. Go forward to 2022. Check my store proc. They say my store proc is not used at all. The thing is that this query ID is not the same query ID. What happens in 2019, you have something, this is a query ID is number 2. This belongs to my store proc. And there are queries number 3 and 4, and queries number 3 and 4, you can find this query store variant. And these are 2 queries that Microsoft put these additional things there. And when I go to query store, I can see them. So this is, this thing is with query variant 3, and this thing is with query variant 1. So this exists as a separated queries in query store, but there is no 2, because 2 is not executed at all. 2 is delegated to 3 and 4. And you can calculate this, but your scripts will be broken. So this thing will not work. So I need to rewrite this script. It's not impossible. So you can go here. I think I have it. Yeah. So here and do some mathematics, and you can get this 130 milliseconds is the average execution time for this. And I can check this here in DMV stats. It is 132. milliseconds. So it is basically, I can get this information from query store, but you need to rewrite to a queries. So if you have monitoring tool that relies on this, if you write some queries that you use with store procedures or object IDs, this will not work anymore with PSP. So this is the thing, especially when you switch with when you switch between 19 or 22, or when SQL Server decides to use PSP or not to use PSP. So if you don't use PSP and you're in 160 compat level, you will see your store proc running in query store. So now I will execute this thing, and of course I will see my, so number 2 is executed, and this is executed 10 times. But now when I switch to, oh, sorry, when I switch to 160 and I executed 4 times altogether, so I should have here another plan or plans and see 14, but I still see here 10. So according to query store, this store proc is not executed at all. This could be a problem, and that's the reason why I tell at the beginning that this feature can help a lot of to customers who do not track, do not have this big teams dealing with performance troubleshooting and so on. So if you have really problems with parameter sniffing that are years ago and you did not fight against them, it's not likely that you will look at execution plans, and it's not likely that you will check cache, and it's not likely that you use query store extensively. In that case, this could be acceptable that this thing doesn't work. So there are workarounds to do this, but basically, if you have monitoring tools need all these guys needs to adapt their monitoring tools for 2022. Again, it's not a big deal. It's a feasible, so I'm fine with this. If I have feature that can break a bit my scripts, I can fix my scripts, and a feature does a good thing, so I can still use it. For me, this is not something that it's not. I will not use this feature because it breaks my script. So, but you need to be aware of this. Okay.
One question from Alessandro. Do you need query store enabled for PSP to work?
You don't need. The thing is that this thing, it uses query store, but it's not necessary to be enabled. I will now disable it. So it is used for max DOP feedback, for CE feedback, for memory grant feedback. You need to use query store. Without query store, no those features. This is the important thing for those who are attending this session. If you are not familiar with query store, you should start learning this, not only because of a query store itself feature. There are many things on top of query store in 2022, and I guess that will be more in future versions. So it makes sense to use use query store. I will disable now query store. It's not, it's DB2, it's my database. And let's go to 160, and it's still there. It's still using. So it uses, now of course I cannot use this, I know. This should not work now. Yeah, it's basically, I did not clear it.
Oh, okay.
So the disabling query store doesn't mean you clear it. So now I clear it. So let's go again to PSP. No. So I have too many open windows. Sorry. Let's go here and execute this. It's a good thing that it still works, but now we should not get here anything. It's stored somehow. It's basically, I think it's used under the hood, but or they have some additional option to store this variant things. But it's not required. Okay. Any other question?
One is about the scripts you had for checking the execution plans. Arpit wants you to paste it into the chat, but I directed him to.
Here is the entire presentation, and all chat things are here. I will just put it here. Here it is.
Perfect.
So you can download everything.
Yeah, exactly. I pasted the same link to your sessions repository. So
okay, Very well. So the next thing is skipped reasons. So it doesn't work with optional parameters. It doesn't work with this, doesn't work with that, but here it doesn't work also with all these things. I will go back here with query. Actually, I don't need query store at all. So there are 38 reasons altogether. So you need to be in 160 compat level. There are some obvious reasons, but there are some esoteric reasons also. Compat level system doesn't work with system DBs. If you disable this feature, parameters PSP optimization, this is a database scope option. Of course, it won't work. Table variable, interesting thing, something with local variable, table variable, multi-state multi-value value function in memory LTP. When you force the plan, when you force the plan in query store, it will respect this. It won't try to optimize it. When you have recompiles and so on. And parameter sniffing disabled, as you asked at the beginning. So if it's a parameter sniffing is disabled as a phenomena, then PSP will not trigger. Let's go a bit with and play with some of them because we have just a few minutes. Table variable. If you have table variable, and I change slightly my code here, I have a cross join with table variable. It doesn't change the value. So let's go here and show that this thing will work. So just to it works. But when I execute this thing, SQL Server will not use ESP. I have a here session for this. There are extend event session. You have a code for this session. I will just enable this session here for start this session for my database. And I have a here. So I don't need this to see here. You see there's variant things. So parameter sniffing doesn't work because I use table variable. When you go to extend event session, it say, okay, this is because of table variable. So I can just include this text. It's my store proc, and it doesn't work because of table variable. So if you have table variable, forget about PSP. Then if you have a temporary table, so I have exactly the same code with temporary table. So it works. So it doesn't work with table variable, but it works with temporary table. But it works only if you have select. If I have insert, or in this case, I have an insert into, it won't work. You see here, similar to interleaved execution when somebody play with this feature. So it doesn't work when you have an insert, like or insert in table variable. Now it says serial plan. So basically, it won't work here. So when you go here and you will see the reason why is unsupported statement type. So it doesn't work with table variable. Local variable. It won't work with local. Even when you put here local, I just put local variable in addition to select. It doesn't have anything with cardinality. It doesn't have anything. I just put it hard coded here, X, and put it in select. It won't work. So it makes sense if you use it here, because using local variable within a database will have exactly the same effect as disabling parameter sniffing, like optimize for unknown, but this won't work, which is basically should work here. So what does here local variable, but you see it doesn't work. And when you go here and you will find has local variable or something. Yeah, here's has local variable and it won't work. And recompile. When you have with recompile, I don't have time to check all of this, but I will go with the code. When you have read recompile, it won't work. Makes sense with non-cacheable reason. When you have option recompile, it won't work with a different reason with recompile flag. But in both cases, it makes sense not to try to optimize because this thing is not in cache. In both cases, SQL Server does not put this in cache, and it makes sense. It makes no sense to try to optimize something to have more files, more plans, because I will anyway recompile all of them. Obvious reasons, if compat level is 150, of course it won't work. It's not different than 160, and you will get this reason. And when you disable this feature, of course, it's a trivial. When you disable parameter sniffing, you can disable parameter sniffing. Of course, it's not. You should not do this. But if you disable it at the database level and also at the store proc level, it won't work. And you will see param sniff disabled. And also optimize for unknown, it won't work, but it's not covered by extend events. So extend events does not anything about this. So it will not arise here reason for skipping, but it won't work. So let me show you here this when I just execute this. So see, it doesn't work. So it is basically this plan because we optimize for unknown. There is no optimization, but you cannot find here anything. It's basically just maybe back in extend events. User defined function will work, but it will have serial plan, of course, because they have a user defined inhibits parallelism, so it will work. And when you force the plan in query store, it will respect forcing plan, so it won't work. There is a reason use plan, you already force the plan, and of course doesn't make sense to optimize something where I took responsibility from optimizer to do this. And there are some other reasons. I don't have time to check this, but there is a very important reason, is skewness threshold not met. So that means there are cases, and I have a similar database here. I will just show you let me show you the first example, and that's all. Then I'm done with this. I have this one in the PS1. This is my database. Here is my distribution, 500,000, 108,000, and so on. This is not good enough for parameter sniffing. So parameter sniffing won't work here because SQL Server thinks this is not good skew, not skew enough for PSP optimization. So this is a very important thing. That means the SQL Server needs to figure out first, is it skewed enough, and then you need to skip local variables, stable variables. You don't need to insert. You need just to use select and so on.
But if SQL Server thinks that the data is not skewed enough, and then it becomes skewed, will it realize that it should start using PSP?
Oh, I guess yes, when it recompiles the plan, but still plan is in cache. I don't think that this will remove plan from cache, but I mean, when this significantly, when we have a skewness in distribution that suddenly happens, that usually means that SQL Server will recompile the plan. It will create again. And it will consider this again. But the thing, when the plan is in cache, it won't consider anything. So far plan is in cache, it will not touch anything. And basically next time when plan is removed from cache, starts the entire process, and PSP is a part of it. So, and then PSP will recognize, you are skewed, skewed enough for my feature, and then I will go with this feature.
Because I'm just guessing that the if it's skewed enough, it's going to be a threshold where basically one order could put one customer to make it skewed enough, but that's not going to cause a recompilation of all plans.
I did not try to make it to trigger it somehow by calling different combination with it. It might be, but I don't think that the way how I call this store proc affects this decision. But this is just my opinion. So I did not play enough with it. It might be that you can somehow trigger when SQL Server see, okay, I call it with only with 1 and million. Then I should trigger this. But as I said, it's not documented, so I can just guess, and my guess can be, of course, wrong. So just to summarize, it reduced the problem with parameter sniffing. For some customers, it could be significant reduce. And definitely, I'll show you cases where this will help. It works only with equals operator. You can forget greater than, less than, between. You can forget optional parameters. There are many other limitations. Table variable, local variable. If this skewness with threshold is not reached, it works only for select. And you see issues with caching, so you cannot look at the plan in the cache. Plan is disappear, and you have problems with query store, but you can somehow overcome these issues, and your existing monitoring solutions may stop working. So this is just summary. And in addition to this, you have a I just put I did not want to go this because the topic is 2022. You have the last file here in my repository, shows you how to solve this problem, actually, how to overcome this problem in SQL Server 2019 or previous versions. So if you cannot use option recompile, if you cannot use all these things, you can have two different procedures dealing with this and some here code, and this will work in both cases even without parameter sniffing. So for those who will have problem with this secondary parameter sniffing in with PSP. Okay, I'm done.
Very good. I guess there will be updates to this feature from now and until it becomes generally available, but also with CUs. The first CUs will definitely.
Yeah, it could be. It's still preview. It might be that they will not include it at all. So there is no guarantee for anything. And this is according to release candidate 1, it is likely that you should not expect significant changes here. But yeah, basically, let's see what will happen. And this is this feature has a great potential.
Yes.
And maybe it's in next version that will cover other cases that I mentioned, like optional parameters and so on. The fact that we can have multiple plans for a store proc is a huge step in the right direction, I would say, like this. So they can have, I need to create 2 store procs, sub store procs with this. I would like to have here first, for instance, to let me to define boundaries. So then I define the store proc, say, okay, boundaries for this is this and that. And then basically I can decide what is the big customer for me, where I would expect this, and I can edit the store proc. In case it's a bit responsibility from my side, but then it would be better better for that. So we might expect such things. So I would rather use an out-of-box feature than to write several sub-store procedures and maintain them later. So it's about maintenance, yeah.
Yeah, I talked to Anders Petersen when I was on SQL Saturday in Oslo, and he had tried, I think this was not even a release candidate, it was the CTP, just tried to run a normal production workload. He's a DBA for, I think he said something like 6,000 databases. And they saw, without doing anything, just upgrading to SQL Server 2022 on a test environment and run a production workload, it was 20% faster, but touching nothing.
Yeah, that's true. So when you have a large amount of servers and database, you don't have time to catch this, to optimize exactly. I mean, if I would have 6,000, even if I have knowledge to fight it, I don't have time to cover all these things. But of course, you will automate things. And if this is overall bring performance win, then it's fine. But again, this is when you have such cases, you might expect regressions. And I like when I have some features, new features, I like to know about the regressions so that in case that I need them, I need to know how to fight against them. So of course, I would like to not to touch this at all, but I'm afraid that in many cases, if you have 600 databases, you will have such workloads where one or multiple features will not work properly. And then you need to do something. So I cannot just wait until next version to fix this regression.
But I mean, Microsoft came a long way from, not too long ago, we had to enable a trace flag on.
Yeah, sure, absolutely. Yeah.
Now, more or less everything is in database scope configuration. So you can actually, if I have 1 or 2 databases where I see regression from upgrading, I'll just disable the features on those and go back to 2019 mode, basically.
Yeah, absolutely. This is a great thing with all these intelligent query processing features. They are basically, I do not expect they will not solve all problems, and they will introduce some regressions, but it's easy to fight against this. You just need to identify regressions and basically disable particular feature on a particular query, and then continue with that. And as you mentioned, that was for parameter sniffing in 2005, you had to use trace flag to disable at this instance level, which is, now it's just the setting. So it's a great flexibility. Absolutely appreciate this. Yeah.
Milos, one question, one last question. The thing is, for example, is there a possibility in any way, like, for example, we have a workload running, and like from first or until 3 weeks, it just goes fine. But when it is coming to the end of month, we have then the stored proc starts like slowing down, everything slows down because of the bulk of data. It slowly, gradually increases. But is it possible like we change this compatibility parameter like on the fly? So like when it is like 3 weeks, we change it to a different one, and at the when it goes to the almost in an end of the like end of the month, and we change it back to, so it uses a different plan. So
You
if
can
we use a
you
query
can
store, yeah,
Yeah,
sorry, yeah.
you can change this even in 2016, 2017. Basically, you can use actually from 2017, I think, use hint. There is a use hint option, and you can put this for any query where you might think that this query will work better with old cardinality estimation or old compatibility level rules. There is a two options. There is a force legacy cardinality estimation, which affects only cardinality estimation component, or you can just go back and tell SQL Server apply all rules that are 2012 rules for particular for this query and put this hint at the end of the query. This is not a dangerous thing. So basically you don't change the code. You put this at the end. That is the very last statement. And then when you think that you don't need these rules anymore, you can remove, or you can have two different store procedures. If you want to maintain like this, to have, I will switch this to one or to another. So for big data, small data, whatever. So you can do this. This is a great thing. So as Magnus said that previously, we had to use trace flags in the past for this, and to put trace flag on the server, you need to have sysadmin rights at that point. So it was not possible at all to use. Now as a developer, you can use this hint at the statement level of store proc or query, which is a huge improvement. Yeah, you can use either two store procs. You can put a hint, use hint compatibility level. I know you can just Google for this, but the option use hint and find the proper, you can go back to any compatibility level. So of course it worked backwards. So you cannot just now use
Okay,
160.
okay. So in that case, we do not have to really modify at a system level. We can just use it in every proc or in
Yeah,
any of the SQL.
if you disabled it on system level, all your queries will behave as in the previous version, and this is not what you want to see. In many cases, you will see benefits of moving to the latest compat level session, and basically whenever you try to fix something, you can do this. This is a great thing to do this on just the statement level.
Oh, okay. But in that case, what should be the level at a system level then? For example, if I say in my system, if I set it to compatibility level 120, and if in my SQL, if I'm using 140, so can I use it? It will still work, or it will just redirect itself directly to the 120 because it is in a system level, it is set to 120.
It can work 150. It should work 150, but I'm not sure. So I did not play in this direction. It should work if you have a version that will support 150. If you are, for instance, you have 2019 and your database is 120 compatibility level, each hint 150 should work. So you can go forward, but you need, of course, to cover this with the version. Usually you have opposite, so you don't want to do this. Usually you have there are performance regressions, but you will have them for some cases, for some corner cases, and you will have more benefits usually than regressions per compat level. So you should do opposite. Enable it as soon as you find something which might work better with old. Usually it's related to cardinality estimation. You have to go back maybe to 110 compat level, and it will work better. But it is opposite. You should work with the current compat level, and for some cases go back to the old versions, not opposite.
And maybe if you have cardinality, for me, I use legacy cardinality estimation as the database setting for many systems. With the CE feedback, I might be able to change that. I haven't tested it enough, and it's also in preview. But the CE feedback could solve many of the problems, I think.
I expect again some kind it will reduce. So you will still find cases where this feedback doesn't cover something, but it will reduce. You will not end up with, I don't know, estimation of billion when you have few rows, or you will end up on or opposite, but in the middle of the similar with adaptive join. adaptive join will work well. You will not let you to have an index key lookup for 10 million rows, and you won't have index scan for 5 rows. But what will be between, it's basically still it can go in both directions.
Yeah.
Yeah.
No, but I think I might be able to start fighting it on query level. For the systems I work with, some of the databases, there are just too many queries that suffer from the new cardinality estimator. So I put the whole database in legacy cardinality estimation mode because we don't have time to fix all the queries. So
that's legitimate. Yeah. It's up to maintenance. It's a maintenance thing. So if you need to touch few queries only, I will put a hint. If I need to touch 35 queries, then it's basically, you need to touch this. You go to code repository to ensure that you don't, that you don't override these things. So if it's a maintenance thing, if you really don't have benefits of new features, and it can happen, you have such workloads that there are legacy workloads that work fine with all cardinality, then basically, of course, I would rather not use this feature. Yeah. In that case, yes. Yeah.
I'm going to leave you to your workday, and I'm going to go back to my day job. But thank you for coming. The last question from me is, are you coming to Seattle?
No, unfortunately, I'll be online there. I have a session, live session there. We have in the middle of World Cup. Actually, World Cup is a big event for our company, and we are in the last preparation before the World Cup. So it was not just a timing. It's not something for me. But I'll be online all the time, and I will deliver session, I think, on Friday live.
Cool. Then I'll see you in person at some other event, but maybe I'll say hi online.
Yeah, sure.
Cool.
Thank you for hosting me, and yeah.
Thanks for coming.
Have a nice day for everybody, and thanks for attending the session.
Great session.